Hello, here I am going to show you how to design 5-level Cascade H-Bridge SPWM Inverter in MATLAB Simulink software. These are the components required to design this model. First, drag all these components, all these blocks into your new model. After that, design the circuit shown here. This is the main circuit of 5-level Cascade H-Bridge Inverter, and this is the PWM generation circuit by using IPD PWM method. I will show how to design these two circuits in MATLAB Simulink software. First step is drag all these components into your new model. First select the first design main circuit diagram, that is a 5-level Cascade H-Bridge circuit. After that, I will show you how to design a PWM pulse generation circuit. First, drag the components needed for designing the 5-level Cascade H-Bridge inverter. The first component is IGBT switch, and next DC voltage source, and series RLC branch for load element, and scope block to observe the output waveform, and the voltage measurement block to measure output voltage of the inverter, and power glue block to work with all simple system models. These are the components needed for designing the Cascade 5-level H-Bridge inverter. First, I will show how to design this Cascade 5-level H-Bridge inverter. After that, I will show the PWM generation. This one I am taking switch S1. Switch S2, switch S3, switch S4. Select them and drag. Switch S5, S6, S7, S8. Connect all these blocks as per the circuit shown previously. This is the circuit of 5-level Cascade H-Bridge inverter. Here I am giving supply voltage. I am taking 50 for source 1, DC source 1, and 50 for DC source 2. And here the load element I am taking resistive load. Select R, give some values 20 ohm, and give 20 ohms here, and type the name. Series RLC circuit. Here give the name R load. Now let's design PWM generation circuit. The components required for PWM generation circuit are: one is AC voltage source for generating reference signal, that is sine wave, and next one is for generating triangular wave we need a repeating sequence block. That one. Next, for comparing the reference and triangular wave, we need a relational operator. Drag that one. And for inverting the pulses, You need one logical operator, and to taking out the signals, you need out block output port, the port output port, and also you need one mux for combining the input signals. If you pass signals from one block to another block, you need a go to block and a from block. Go to block to send the signal to the other block, and the from block to receive the signal from the other block. From block, this is from block. Okay, with these things I will design the PWM generation circuit. This is for generating the sine wave. This is for generating the triangular wave. This is sine wave. This is triangular wave. Triangle 1. Need four triangle waves. 2, 3, 4. 4 triangle waves. And for comparing reference and carrier signals, you need a comparator. Here I am relational operator I am taking as a comparator. Here I am giving the condition is greater than or equal to. This is comparator 1. Comparator 2, comparator 3, comparator 4. Take one measurement block for taking the sine wave output. The sine wave means it is reference wave. Here to the comparator. One terminal of the comparator, and the second terminal of the comparator give triangular wave 2, triangular wave 3, and triangular wave 4. With this, we will get 4 pulses, but here we have 8 IGBT switches. We need another 4 pulses, PWM pulses. So here I am using logical operator for inverting the pulses. NOT gate I am taking. Four NOT gates. Total 8 pulses you can generate with this. Previously, I shown the image of PWM pulses to the IGBT switches. According to that image, that figure, this pulse we should have to give switch S1. Take simply this is 1, and this pulse we should have to give switch S2. This pulse we should have to give switch S3, and this pulse we should have to give switch S3, and this pulse we should have to give switch S5, and this pulse we should have to give switch S6, and this pulse to S7, and this pulse to S8. This pulse to S8. Now create subsystem for this PWM pulse generation. Just to name it PWM pulse generation. PWM pulse generation circuit. Now to observe PWM signals and to observe reference signal and carrier signals, I am taking the help of go to block and from block. These two blocks will pass the signals from one block to another block. Here, take go to block, I paste it and put name it is sine for taking signal of sine, and take another go to block, which is for taking the signal of triangle wave. Let's try one. This is for sine wave, taking the signal of sine wave. Take the signal, means it will pass the signal to the other block. Triangle 1, triangle 2, triangle 3, triangle 4. And put name, this is sine 1, sine, and make it available to global. Apply, and we put name triangle 1, make it available to global. Apply, okay. Triangle 2, make it available global. Apply, okay. Triangle 3, make it available global. Apply, okay. Take one mux block, including reference and including reference signal, there is total 5 signals. If I take 5 inputs, update tags. First one is sine wave, apply, okay. Means I am receiving a signal from there. This is sine. This is triangle. Triangle 2, triangle 3, triangle 4. Just double click, update tags, into triangle 1, double click, update tags, new triangle 2, double click, update tags, new triangle 3, double click, update tags, new triangle 4, and connect them. This mux is used to combine input signals into single vector output. Single vector output. Take one scope block to observe this reference and the carrier signal. And in the same way, here again take one go to block to pass signal to the IGBT switches. This signal is for pulse S1, pulse S2, pulse S3, pulse S4, drag another go to on the from block, go to block and from block to pass PWM pulses to the IGBT switches. We rotate pulse for S1, pulse for S2, pulse for S3, pulse for S4, pulse for S5, pulse for S6, pulse for S7, pulse for S8. Make them like this. Now take from block, you repeat name pulses S1, pulses S2, pulses S3, pulses S4, S5, this is 6, this is 7, this is 8. And again, now double click on go to block, do this, this is for S1 switch, S1, apply, okay, and this is for S2 switch, apply, okay, finally this is for S8 switch, S1, S2, S3, S4, S5, S6, S7, S8, and double click on from block of S1 and update tag and select S1, apply, okay. And here double click and update tag, select S2, apply, okay. Finally double click pulses to the S8 switches and update tag and select switch S8, apply, okay. See, S1 pulses, S2 pulses, S3 pulses, S4 pulses, S5 pulses, S6 pulses, S7 pulses, and S8 pulses. These go-to blocks are passing signal from this PWM generation circuit, and these from blocks, these are the from blocks. These from blocks are receiving signals. Okay, this is the complete circuit of 5-level cascade H-Bridge SPWM inverter. Here you can see the reference and the carrier signals, and here these are the this is the circuit for PWM pulse generation, and this is the circuit of 5-level cascade H-Bridge inverter. Next, I will show how to give values to this circuit to get 5-level PWM output at the output terminals of the inverter. Thank you.